Hi friends, welcome to electronics classes. Here we are discussing transistor biasing. This work has been done by SP Academy in association with VK Lectures. What are we doing? We have different uh, circuits comprising of transistor, and here what we are doing is we are finding the input that I current I input current IB that is moving through the transistor, and what happens to the input current IB after once it passes through transistor and moves through IC and IE. So what we are going to do, we are going to apply Kirchhoff law on both the sides, that means the input side and as well as to the output side. Sometimes here you may see capacitor, but you can neglect these capacitors. These are when you are dealing with DC, this can be neglected. Now let us apply KVL to the input. What is the input? You start from this point and this is your input, because this is the positive side and the negative side will again get connected to the ground, and this is also connected to ground. So this becomes the input side of the transistor or the circuit. So here you have input. Now let us apply Kirchhoff voltage law, input KVL. So what you have, VCC equal to, now once it moves through this side, you get IB here. IB is the current passing through this base. So IB times RB plus, now there is a voltage drop across these two ends. The voltage drop across these two ends is called VBE, base to the emitter. So VB, that value is usually around 0.7 for silicon and germanium 0.3 plus 0.7 volt. Now what you want IB, current flowing into the base or into the transistor. IB is equal to VCC minus 0.7, or you can write VBE divided by RB. So this is the current. Now similarly we can apply KVL to the output. This is the output, and VCE, whatever we are talking about, this VCE, the voltage drop across, this is the collector, this is emitter, voltage drop across this particular terminals C and E is called VCE, right? Now so again applying to output KVL, what you have, VCC equal to, there's a transistor RC, so IC times RC plus VCE. Now what is VCE? Why do we want VCE? We want VCE because we want to find out the drop across this VCE, that is the output. Whatever is coming out of VCE is output with respect to ground. Now VCE is equal to VCC minus ICRC. VCC minus ICRC. Now how will you find out IC? IC is equal to, see, this is a emitter bias, or sorry, not emitter bias, common emitter configuration. So from common emitter configuration, you know IC is equal to beta times IB. This value you can substitute here because you already know what is IB. Beta of the transistor will be given. Then you get IC and you get find out VCE. VCE equal to VCC minus ICRC. Now you can draw a graph between IC versus VCE, or VCE versus IC. We see this along x-axis and this along y-axis. VCE along x-axis and IC along y-axis. So you will have a curve something like this for a particular value of IB. Okay. So first of all, to the input side. Input VCC. What is VCC? 14 volt is equal to IB. IB is given 40 microampere into RB is not given, plus VBE. VBE we can write 0.7. Okay. Now what do you want? RB. RB is equal to 14 minus VBE is equal to 0.7 divided by 40 microampere. So what is that value? 13.3 divided by 40. Am I right? The value is around 40. You can divide, and 330 kilo ohm. So RB value we got. Now we have to apply KVL to the output. So this point VC is given. So VC is equal to 6 volt. Okay. Now what you want? VCE. VCE is equal to VC minus VE. What is VE? The at terminal is connected to ground. So at this point 0 volt. So VE equal to 0, VC equal to 6, VCE equal to 6 volt. Okay. Now applying KVL to the output. VCC equal to IC times RC plus VCE. Now we don't know IC, but we know what is beta. Beta equal to 50, IB equal to 40. So IC is equal to 40 microampere into beta, that is 50. 100 by 2. So that is nothing but 2 milliampere. Now just apply here. VCC equal to 14 volt equal to IC is equal to 2 milliampere. RC we don't know, just write RC. Plus VC is equal to 6 volt. So 14 minus 6, that is 8 volt, is equal to 8 volt divided by 2 milliampere equal to RC. That is nothing but 4 kilo ohm. Milliampere goes to the numerator. Now what else you need? You have RC, everything is ready. 6 volt, 4 kilo ohm, RB value, IC, all the 4 unknowns. So IC equal to IE minus IB. So in a way you can take IB, this is around 0.02 milliampere. IB equal to 0.02 milliampere. So I can write that is equal to 3.98 milliampere, or simply 4 milliampere also I can use. So it will be small difference in your answer. Now once I got IB or IC, I can find out beta. Beta is nothing but IC by IB. IC is equal to 3.98 divided by IB equal to 20 microampere. So this will give me around 199, or you can simply take 200. Okay. Now we can apply, we want RB. So let us apply KVL to the input side. So VCC equal to RB, so IB RB plus VBE. Now there is a two unknown. VCC is also an unknown, as well as RB is also unknown. So give it as equation 1. Now go to the output. VCC equal to ICRC plus VCE. This voltage is VCE, right? Now let this be second equation. Now we have given VCE is equal to 7.2. IC we already have found out, let it be 4 milliampere. Okay, so let us apply here. IC, what is IC? For 3, let's write 3.98. 3.98 into RC. RC value is 2.7K. 2.7K low plus VCE. What is VCE? 7.2 volt. Okay. Now 3.98 into 2.7. What is that value? 3.98 into. See, most of the cases you can use 4 also, but here let us go with approximate into 2.7. So 10.74. So 10.74 plus 7.2. So what is the value you are getting? 17.94. So this is 17.94 volt. Okay. If you would have taken 4 milliampere current instead of 3.98, this would be around 18 volt. Okay. Now leave that. So we got VCC. Now just apply VCC here in this equation. So VCC 17.94 minus IBRB. IB is 20 microampere. 20 microampere into RB plus VBE. VBE 0.7. So 17.24 equal to divided by 20 microampere equal to RB. So what is RB? 17 by 2, that is 862 kilo milliampere. Sorry, micro will come. 862 kilo. So you got RB, beta, VC and IC. Alright, fine. So this is it. So what we have? We have IC or IE is equal to IC plus IB. We will equate it to IC. Okay. Now, but IC is equal to beta times IB. Then we can write IC equal to beta IB. Then just substitute this value. IE is equal to beta plus 1 beta plus 1 into IB, right? IE is equal to beta plus 1 into IB. Now, just applying the KVL to the input. Please listen carefully. VCC equal to IBRB plus VBE plus IERE. Alright, now we want IB. IB is equal to VCC minus VBE minus IERE. So what is IE? IE is nothing but beta plus 1 into IB. So beta plus 1 into IB into RE. Right? Now, this beta plus 1, beta plus 1 IB is there. You can take it this also to the outside. Wait a minute. We will write it as like this. VCC equal to IB times RB plus VBE plus, instead of IE, beta plus 1 into IB times RE. Alright. So beta plus 1 IB into RE is there. IB into RB is also there. So from that you can take IB. So IB into RB plus beta plus 1 into RE plus VBE. Am I correct? So what is IB? IB is equal to VCC minus VBE divided by RB plus beta plus 1 into RE. So this is your IB. So once again we will write here IB is equal to VCC minus VBE divided by RB plus beta plus 1 into RE. Now again you can simplify this. This quantity beta is a very large quantity. Okay, so RB and RE, if it is very large, then you can even reduce it. So how can you put it? IB is equal to VCC minus VBE divided by, neglect this quantity, so beta plus 1 into RE you can write, if it is a very large quantity. If it is given, you can directly substitute. Otherwise, for very small quantity you can. What is IC? IC is equal to beta times IB. So what is IB? IB equal to VCC minus VBE divided by RB plus beta plus 1 into RE into this beta. Okay. Now just let me write the simplified form also. VCC minus VBE divided by beta plus 1 into RE. So beta into beta plus 1. We are removing this RB. What you are getting? Divided by RE. Beta plus 1 into beta. That means you can cancel beta and beta plus 1. So this is approximately equal to your IC. Now here you have VCE. Here you have VCE. Output, to the output, if you apply KVL, what you are getting? VCC equal to ICRC plus VCE plus IERE. Here also you can substitute IER into beta plus 1 into IB. Here also you can substitute IE is equal to beta plus 1 into beta plus 1 into IE equal to IB into RE. Alright, beta plus 1 into IB into RE. So what do we want? VCE. VCE is equal to VCC minus, now this IC, what we can do? What is this IC? Beta times IB. Beta times IB minus beta plus 1 into IB into RE. Yeah. So make this common. So VCC minus IB, you can take it out. So IB into minus IB you can take it out. Beta plus beta times, sorry, this is beta IB into RC. Here RC is there. So beta times RC plus beta plus 1 times RE. 1 RE. So VCE equal to, sorry, VCE is equal to VCC minus IB into beta times RC plus beta plus 1 times RE. Fine. So this is one method. One method means one way to do this problem, considering beta. Now another simple way is this IE and IC are almost similar. Okay, then what will be VCE? VCE equal to VCC minus ICRC minus IERE, right? So that is equal to VCC minus, consider this IC and IE are same, so IC into RC plus RE. Please make a note of it. So given IC 30 milliampere, beta 80, VC 7.6. VC means this particular value. VC equal to 7.6 volt VE is equal to 2.4 volt. Okay. Now what we can do? You are asked to find out VCE. VCE is equal to VC minus VE. VC equal to 7.6, VE equal to 2.4, so that is equal to 5.2. 5.2 volt is VCE. Okay, yeah, fine. Now you are also asked to find out VB. Now VBE is equal to VB minus VE, right? VBE equal to VB minus VE, or VB is equal to VBE plus VE. Now what is VBE? 0.7 volt plus what is VE? VE is given to be 2.4 volt, so that's equal to 3.1 volt. That is VB. Okay, now so VCE also we got. Now RB, let us come to the input side. Now at this point, what is the voltage? What we got? VB, that is equal to 3.1 volt. Am I correct? At this point, with respect to the ground, we have 3.1 volt. So here if we are applying input side, input KVL, VCC equal to IB RB plus 3.1 volt. 3.1 volt, or you can write VB, right? Now what we want? RB. RB is equal to VCC. What is VCC? 12. 12 volt minus 3.1 divided by IB. So IB we don't know, but we know IC and beta. So IB is equal to IC by beta. So that's equal to 12 minus 3.1, that is 8.9. 8.9 divided by beta, that is 30, into beta is 80. Right? So get cancelled. 9, 3, you can write it around. 2, 4, this is milliampere. So 3, 3, 8 are 24. So 24 kilo. Right? Now what we want is RC now. RC, why we want RC? So RE, no? Okay. So now to the output. RC is equal to this voltage drop minus divided by current through RC. RC, that is IC. So VCC minus VC divided by IC. So what is that? VCC. What is VCC? VCC is given to be 12 volt. 12 minus VC is equal to 7.6 divided by IC, that is equal to 30 milliamp. So 12 minus 7.6, that is equal to 12 minus 7.66. 4.4 divided by 30 milliampere. So that is around 0.146 kilo ohm. 0.146 kilo ohm. Now what is RE? RE equal to current through or voltage V RE divided by or V E minus 0, this one, divided by IE. This also megaret. So what is that? This this is 2.4 volt, right? 2.4 volt VE. So 2.4 volt divided by 2.4 volt divided by IE. IE is nothing but IC, that is equal to IC is equal to 30 milliampere. So that particular value is 2.4 by 3, 0.8, 80. So that will be around 800 ohm. Milliampere will go upside. So this is it. 146 ohm, 80 ohm, 800 ohm. 100. So this is the current I. Here there is no IC and RC because this collector, part of it is being from the VCC, part of it is being developed across this RC, which is connected to this point C, and then it goes to RB through IB. Now this becomes IB because it is moving to IB. But here this RC, this resistance is connected to both this base as well as collector, but still we will give this name C, and there is no resistance across or voltage drop across emitter terminal. Okay, so I is equal to IB plus IC, sorry, IE, sorry, total current IC, this is IC, this current plus this current, but here it is I, which means this is equal to IE. That means whatever current is flowing through this RC is also flowing through IE. I hope you got that point. Whatever current is flowing through this RC is also flowing through IE because the total current will not change. Okay, now let us apply Kirchhoff law to the input. VCC equal to I into RC plus IB RB plus VBE, and after that there is no drop. This is the final voltage drop. Okay. Now this particular value I, as I said, I can write it as IE. So that is nothing but beta plus 1 in terms of beta into IB. correct? So beta plus 1 into IB into RC plus IBRB plus VBE. From that we can find out IB. So what is IB equal to? VCC minus VBE divided by beta plus 1 RC plus RB. Right? So beta plus 1 into RC plus RB. Similar to the previous one. Very similar to the previous one. Now we can find out IC. IC is equal to beta times IB. So what is that equal to? Beta times IB means beta into VCC minus VBE divided by beta plus 1 into RC plus RB. Here also you can consider this beta being very large. RB can be neglected and it becomes by RC. Earlier you got IC. Now that point also you can note, if beta is very large compared to RB, beta plus 1 times RC is very large compared to RB, then IC is equal to VCC minus VBE divided by RC. Please remember this formula for IC. Similarly, so now to the output. We have VCC equal to I into RC plus this is VCE plus IERE, there is no 0. Okay. Now what you want? What is this I? I is nothing but beta plus 1. Wait. I into RC. Beta plus 1 into IB. So this is beta plus 1 into IB into RC plus VCE. So what is VCE equal to? VCC minus beta plus 1 into IB RC. So that's it. There is no simplification further. This one you can take. Now find the operating point. Operating point means you have to find IC as well as VCE. IC VCE is the operating point, or VCE and IC. Okay. So from the input, let us go by input side. VCC equal to I times RC plus IBRB plus VBE. Okay, so what is this? I is nothing but beta plus 1 into IB into RC plus IBRB plus VBE. So take this IB outside. IB into beta plus 1 into RC plus RB plus VBE. And what about IB? IB is equal to VCC minus VBE divided by beta plus 1 into RC plus RB. So that is equal to, what is VCC? VCC equal to 20 minus VBE equal to 0.7 divided by beta is 100 plus 1 into RC is 1K, so 101K plus RB is equal to 100. Now here you cannot use that approximation. Okay, so that's equal to 19.3 divided by 201K. That is equal to IB. But we don't want IB, we want IC. So what is IC? IC equal to beta plus beta into IB. That is beta is 100. 100 into 19.3 divided by 200K. So 19.3 you can divide, which means almost equal to 19.3, that is 9.65. K will go, it will become milliampere. So this is IC. Please make a note first. Completed. Okay, thank you. To the output side, VCC equal to I into RC plus VCE. There is no drop across resistance. So what is VCE? VCC minus I into RC. Right. Now what is VCC? VCC equal to 20 minus 1 plus beta. 1 plus beta into IB into RC. So what is that? 20 minus this we can approximate it to IC, right? IC, that is 9.65 milliampere. So 101K into RC value is 1. So beta value is 100. So 101K into IB. IB is 9.65 micro. 9.65 divided by 100. Right, this is milliampere divided by 100. Okay, leave that. So what we are getting is 100 you can cancel it out. So 20 minus 9.65 volt, which is nothing but 9.65, 10.35 volt. See, this is the question, or this is the circuit. You have a VCC and the voltage is being divided across R1 and RC, and in the input side the voltage is fed across R1 and R2, making this VBE or the condition between base and emitter such that it is reverse biased, giving way for amplification in the active region. active region. Now here in the input side, this VCC is being fed across R1 and R2. They divide them equally. Equally means with respect to R1 and R2. Okay. Now we want to find out an equivalent circuit. Now I am just splitting this circuit. Here I am giving collector VCC, the collector terminal VCC. Am I correct? This collector is connected to VCC, and the input side, what I am doing is I am again connecting it to another voltage of VCC. So very same circuit. I am just separating this. Here I am giving VCC. Instead of this terminal, here I am giving VCC. I am using two batteries or two power supplies, voltage sources. Now this circuit, look at this circuit or this loop. To find out the voltage across this, that is on base VB, this is point B, with respect to ground, what is the voltage? This is the voltage, or this is the voltage drop that is across happening across this R2. Now if I want to find out VB, this is nothing but voltage across R2. Now what is that? This is nothing but Thevenin's voltage, VTH. Now what is Thevenin's equivalent resistance? RTH. RTH is nothing but R1 R2 divided by R1 plus R2. Thevenin's equivalent resistance is R1 R2 plus divided by R1 plus R2. Now what is VTH? VTH is equal to VCC into R2, voltage across R2, divided by R1 plus R2. Now VCC divided by R1 plus R2 is nothing but the current flowing through this loop. Correct? Now we have got RTH and VTH, and this is the first thing that you have to do when you are getting a voltage divider by a circuit. Find out VTH and RTH. Once you have found out VTH and RTH, just make the equivalent circuit. So this is VTH, RTH, and through the base. This is base, collector and emitter. Now this is similar to that of a emitter bias. Now let us apply the input side KVL. VTH is equal to IB. Oh yeah, you can write IB into RTH plus VBE plus IERE. Right. Now what is IE in terms of beta? In terms of beta, IE equal to beta plus 1 IB into RE. IE equal to beta plus 1 IB into RE. Now this, let it remain as IB into RTH. plus VBE plus beta plus 1 into IB into RE. Now from here we can find out IB. So what is IB equal to? IB equal to VTH minus VBE divided by IB. So RTH plus beta plus 1 into RE. Correct? Beta plus 1 into RE. Now we want IC. What is IC? IC is equal to beta times IB, which is equal to VTH minus VBE divided by RTH plus beta plus 1 into RE into beta. Now simplification can be done. This beta plus 1 RE is very much greater than this RTH because this is Thevenin's equivalent resistance. Thevenin's equivalent resistance will be smaller than the resistance R1 and R2. Okay, so smaller than the resistance R1 and R2. So beta plus 1, beta is value of around 80-100. So this quantity is a large quantity. So just simplifying. So once again I am telling this simplification has to be done only when this RTH is very much smaller. It should not be like 20 and 50. It should be around 1 and 100 in that ratio. Then you can neglect, or of the order 1 and of the order 10, 100 in that way. Okay, so IC is equal to VTH. Please remember this formula. VTH minus VBE divided by beta plus 1 into beta. This can be removed by RE. Please remember this formula. Yeah. Now you see we have output KVL. Now what we have found out is just now IC is equal to VTH minus VBE divided by RE. Leave it like that. Now going to the output KVL, VCC equal to IC times RC plus VCE plus IERE. Now here what we are doing is we are assuming IC is equal to IE. So VCC equal to IC into RC plus RE plus VCE. Now what is VCE? VCE equal to VCC minus IC into RC plus RE. Now IC is nothing but this value. So our aim is to find out first VTH and RTH. So what is VTH? VTH is equal to VCC into R2 divided by R1 plus R2. So what is VCC? VCC is nothing but 22. 22 into R2. R2 3.9. 3.9 you can take 4. Okay. Divided by R1 plus R2. 3.9 plus 39. That is around 43. Okay. So this value is around VTH is equal to 2.1 you can take. 1 by 11. So this means be around 2.1 volt or 2 volt, you can take, no problem. Now we got VTH. Now what is RTH? RTH is equal to R1 R2, that is 3.94 30, you can take 40, 30 into 40 divided by 4 plus 4, 40 plus 4, so 44, 4 into 40 divided by 44, so this value is around 3.5 3.5 kilo ohm, because all are in kilo ohm. So this is 3.5 kilo ohm, this is 2 volt, 2.1 volt. Okay, just check the value once again, VTH and RTH. Now once we got VTH, RTH, the first thing that we can find is IB. We can find directly, we can find IC. IC is equal to VTH minus VBE divided by RE. What is RE? RE is given to be 1.5 kilo. So VTH is 2.1 minus VBE is 0.7 divided by RE 1.5. Right? So 2.1, that is 1.4 divided by 1.5. So this means almost around 0.9 milliampere. Now once we got IC, what is VCE? VCE equal to VCC minus IC into R plus RE. Sorry, RC plus RE. Now what is VCC? 22. Please don't confuse with VTH and VCC. VTH is different, VCC is different. Values are different. We are just splitting. So VCC equal to 22 minus IC is around 0.9. 0.9 into RC plus RE. What is RC? RC is given to be 10. RE is 1.5. So 11.5. So this value is around 10. This value 0.9, this will be around 10. So 22 minus 10, which is equal to 12. So VTH is equal to 5 volt. RTH is equal to R1 R2. So 10 into 5 divided by 15. So 10 by 3 is RTH. Leave it like that. Now what we want to find out? We want to find IC first. IC is equal to VTH minus VBE divided by RTH. Sorry, RE. Divided by RE. Yeah, RE. See, actually this is also not required. RTH is also not required. So VTH minus VBE divided by RE. What is VTH here? 5 minus 0.7 divided by RE. RE value is 2.2. So this is 4.3 divided by 2.2. So that means around 2 milliampere you can write. Okay. IC equal to 2 milliampere. Now what is VCE? VCE equal to VCC minus IC into RC plus RE. RC plus RE, that is equal to VCC. What is VCC? 15 volt. So 15 minus IC 2 milliampere into RC value is given to be 3K. This is 2.2K. So 3 plus 2.2, 5.2 K. So 2 into 5.2 is 10.4. 15 minus 10.4 equal to 4.6. Yeah, I don't.
Now for the students, here is the greatest news. SP Academy, in association with VK Lectures, has been conducting demo classes for CSIR NET and KSET exam since 18th November 2022, which are absolutely free and any aspirant can join without any registration. Till now, around 250 members have joined our group, and interested participant can join the WhatsApp group using the link, or you can always feel free to contact us. WhatsApp group link and the contact details are given in the video description. Thank you for watching the video. Have a great day.